You see, this is a junction. At the junction, these are the two incoming currents. One is a I1, another is a I2. And this is another current, that is a I3. So this current is the outgoing current. And this is the point of all currents are meeting. This point is called junction. So by uh, at the junction, there are the incoming currents and outgoing currents. And to find I1, I2 and I3, we use the Kirchhoff's junction law. That is I1 plus I2 equals to I3. And this is called Kirchhoff's current law. According to Kirchhoff's current law, incoming currents equals to outgoing current. And there is another type of the circuit. For example, it is a resistor. First resistor R1, and this is the second resistor R2, and this is the third resistor R3, and this is the battery. We call it as a EMF, a cell, and here is a R4, and this is there. Now here the point A, from point A, if you are moving in this way, you first go to R1, then go to R2, then go to R3, then go to the battery and come back to the R4. But what is the problem? Problem is that the endpoints A and B are the endpoints are not connected. When the endpoints are not connected, it is called open circuit. It is called open circuit. So in open circuit, we cannot use Kirchhoff's voltage law. For open circuit, you cannot use Kirchhoff voltage law. For using the Kirchhoff voltage law, is important that the endpoints must be connected. That is, the point A and the point B must be connected by some wire. So when A and B are connected, A and B, A is the starting point of the circuit, B is the end point of the circuit. Starting point and end points are connected. When the starting point and end points are connected, then it is called as a closed circuit. It's called as a closed circuit. So Kirchhoff voltage law, that is a KVL, can be applied only for the closed circuit. You cannot use it for the open circuit. Here, for example, we got a circuit here, A, B, C, D, A again. So here see, A, we got the A. Now suppose you are walking, suppose this is a road and you are walking along this road, and while you are walking, you are coming back to the point A here. So this is a closed circuit. That means when you start from a one point and keep on walking and come back to the same point, then it is called as a closed circuit. Here in your textbook, there is a technical word traced. So when you trace the circuit from a given point and come back to the same point, then it is called as a closed circuit. Now see the another part of the circuit, that is, you start from walking from A here, you came to E, from E to F you gone here, from F to G you gone here, and G to H you gone here, H to I you gone here, but you are unable to go from I to D because there is no path available from I to D. You cannot trace the path from I to D. So the A, E, F, G, H, I is a open circuit. And it is also called as a loop. The closed circuit is also called as a loop because here, suppose you start from A. So we say closed loop A, B, C, D, A. Like this we write out because A, B, C, D, A is a closed loop. But the D, A, E, G, H, I, this is not a closed loop. Not closed loop. Why? Because the endpoint, these are the endpoints and they are not connected. Unless and until you connect the D and I, it is not a closed circuit. Suppose I connect them by a wire. Then now DA, after connecting, it has become what? It has become closed loop. Kirchhoff voltage law can be applied only for the closed loop, and if it is an open loop, you cannot apply the Kirchhoff voltage law. In today's video, I am going to talk everything about a closed loop, and we need to find out the various values of currents and EMFs and voltages. For example, consider a closed loop A, B, C, D, A. So, what direction you are moving? You are moving clockwise direction, and while you're moving, you're coming back to A. So, inside the box, we show by what direction you are moving. So, you are moving the clockwise direction. Therefore, this arrow mark is showing, it is showing the path along which you are moving. So, first you move from A to B. After that, you move from B to C. You move from C to D. Then again you move to D to A. You are coming back to the point A, where from where you started. You started from A and kept on tracing the path, and you are coming back to the point A. So in that case, we say the completed path. The path is getting completed, and if it is path is completed, then it is a closed circuit. It is a closed loop. And what is the voltage between AB? That is a VAB. What is the voltage between BC? That is a VBC. The voltage between C and D, VCD, and the voltage between D and A, VDA. As well as there is a EMF E1 and the EMF E2 are present in the circuit. So there are two EMF sources and the rest are resistances. So according to the Kirchhoff voltage law, it is telling us that addition of all voltages, that is a VAB plus VBC plus VCD plus VDA, as well as the value of all EMFs. The value of, here are the two EMFs, one is the E1, another the E2, that must be equal to 0. That means all potential drops and all EMFs added together, you will get 0. This is nothing but Kirchhoff's voltage law. This is nothing but Kirchhoff mesh law. This is nothing but Kirchhoff's second law. So what is the definition of Kirchhoff's voltage law? Now what is the definition? In a closed loop, a closed circuit. So it is a closed loop. A, B, C, D, A is a closed loop. It is a circuit as well as. Why it is called circuit? Because there are the EMF cells, there are the resistors, there are the various components. Therefore, it is a closed circuit. It is an electrical network. And all these are called electrical component. R1, R2, R3, R4, etc. They are called electrical component. Then algebraic sum of potential differences. What is VAB? VAB nothing but potential difference between the point A and B. What is VBC? Potential difference between the point B and C. What is VCD? Potential difference between the point C and D, and so on. So the algebraic sum of potential differences for components. What are the components? R1, R2, R3 are the components. Plus algebraic sum of all EMFs. In a circuit, not necessarily there is a one EMF. There may be more than one EMF source. For example, in this circuit, there are the two EMF sources, that is the E1 and E2. These are the two EMF sources. So addition of all potential differences plus addition of all EMFs is always equals to 0 in a closed loop, in a closed mesh, or in a closed circuit. So that is nothing but definition of Kirchhoff's voltage law. Here we got a electrical circuit, and suppose we consider the closed loop A, B, C, D, A. Closed loop A, B, C, D, A. That means we shall be moving in this direction. So we trace the path along which we show it by the arrow mark inside the circuit, inside the closed loop, inside this box. We show what direction we are moving. Now suppose we are moving from A to B, then B to C, then C to D, and D to A again. So we completed the tracing from A to A. Now when you are moving from A to B, this is the direction of current. You see, this is the direction of current. So current always flows from higher potential to lower potential. So while moving from A to B, you are moving in the direction of current. So this is a higher potential. It can be shown by the plus sign. And where the current is going? The current is going to the point B. So this is the lower potential. So whenever we are apply the Kirchhoff voltage law, first of all we have to decide the plus and minus. From where the current is flowing is a plus, and where the current is going, that is a minus. From where the current is flowing, that is a plus, and where the current is going, that is a minus. Now when you came to the B, what will happen? The current is opposite direction. The direction of the current is towards you. It is, you are not moving in the direction of current. So this direction where you are meeting an arrow mark, that is a minus, and it would be the plus. You are moving in the opposite direction of the current. After that, as soon as you come to the C, again you are moving in the direction of current. So this side is a plus, and where you are moving to the point D. So where you are moving, so you are moving in the direction of current. So opposite side of the resistor is marked with the minus. So similarly D to A, we are moving in the direction of current. Therefore this side is plus and this side of minus. So the very first step while applying the KVL, to decide the plus and minus. Okay, so from where you are starting, okay, if you are moving, in the direction of current, then from where you starting, from where you starting is plus, and where you going, is minus. So you have to decide plus and minus. That is the first step of application of KVL. Whenever we apply Kirchhoff voltage law, first of all we have to decide the closed loop in a given network. This is a given network. In this network there are many closed loops. So we have to decide the closed loops here. We have to select, for example, this is the one closed loop. So we have to select the closed loop. This is the one closed loop. Now what is the another closed loop? The another closed loop is this one, this. When you are walking, you should be able to come back to the same position again. So we came to the, so this is the another closed loop. Is there any more possibility to get the one more closed loop? Yes, we can get one more closed loop here. So if you start from here, you move like this, like this, like this, like this. So this is the another closed loop. So in a given network, there can be more than one closed loop. There may be the 2, 3, 4, any number. It depends upon the size of the given network. The number of component in a given network, the number of closed loop may vary from one network to another network. Can you guess how many closed loop in this network? So first one is loop A, B, D, A. This is the first loop which is closed one. Then the loop B, C, D, B is even the closed loop. The third one A, B, C, E, F, A, and one more possibility A, D, C, E, F, A. So these are all closed loop in this given network. Now for this closed circuit, how to apply Kirchhoff's second law. Applying Kirchhoff's second law means developing algebraic equation in terms of potential differences and EMF of a given closed loop. So we have the closed loop. First closed loop we are selecting A, B, D, A. We are going to select this first closed loop, and here are three unknown currents I1, I2, I3. We have to find I1 equals to question mark. We have to find I2 and we have to find I3. That means there are the three unknown currents flowing in the circuit, and we have to find the values of these currents. Since the three unknowns are there, therefore we need to get three equations. Before starting to develop the equations, first of all mark plus and minus. So A is the plus and here is the minus, and here is the plus, here is the minus, and here is the plus, and here is the minus. How I decided plus and minus? So from where you are starting, suppose the current, we are moving in the direction of current, and current flows from higher potential to lower potential. So from where the current is starting, that is plus, and where the current is going, that is minus. So for A to B, current is starting from the side of A, so side of A positive and the side of B is negative, because current is moving from A to B. So A side is positive and B side is negative. Similarly, for BD, current is starting from B going to the D, therefore B side is positive and the D side is negative. After deciding plus and minus, we have to we have to develop the equation. Before that, for VAB, I have to get the VAB. VAB nothing but we are moving from plus to minus. So you are going from plus to minus. So write down minus here, and the potential difference nothing but product of resistance and current. So VAB equals to minus 3I1. After that, VBD. VBD nothing but the resistance value here. Resistance value is 6 ohms, and so the VBD is nothing but you are going from plus to minus. So plus to minus, if you are going to minus, so write down the minus here. When you are moving from higher to lower potential, the symbol of this one is minus because there is a potential drop. Therefore, it is 6I3. And after that, you are moving from, you came to the D here, VBD over, that means we came up to the D. Now D to A, so that is a VDA. VDA nothing but, as you are moving from D to A, you are moving opposite direction of current, you are moving from minus to plus. Therefore, write down the plus here, and after that, you write down what is the value of resistor. Here is a 4 ohms, and the current value is I2. Therefore, it is a 4I2. Now, so equation, the algebraic equation for this closed loop ABDA, nothing but VAB plus VBD plus VDA equals to 0. That is minus 3I1 minus 6I3 and plus 4I2 equals to 0. This is required algebraic equation for the closed loop ABDA. Now we will develop one more equation for the second closed loop. Now select second closed loop ABCEFA. For this closed loop, we start from A here now, that is VAB. I have already marked plus and minus. After marking plus and minus, now let us find out VAB. We are moving in the direction of current. minus 3I1, VAB equals to minus 3I1, then VBC, VBC, that we are moving in the direction of current, and the current flowing along BC nothing but I1 minus I3, and this value is 2 ohms. Therefore, VBC nothing but 2 into, we are moving in the direction of current, therefore minus 2 into I1 minus I3, and after that C, we came to the C. Now C2E, there is no resistor, no cell, so directly now we come to the E. Now C, E to F, there is a resistor, and we are moving in the direction of current, and so we have to get the VEF. VEF nothing but the minus 2 into I1 plus I2, and after that, as we are moving now through the cell 10 volt, and we are moving from negative plate to positive plate, there is an increase in the potential. Therefore, this EMF is nothing but taken as a 10 volt. It is plus 10 volt because we are moving from negative plate to positive plate. Therefore, EMF in this closed circuit, in the closed loop, is nothing but plus 10 volt. Now, according to Kirchhoff voltage law, summation of all PDs plus summation of all EMF equals to 0. So, summation of, that is addition of VAB, VBC plus VEF plus EMF equals to 0. That is nothing but minus 3I1 minus 2 into I1 minus I3 minus 2 into I1 plus I2 and plus 10 equals to 0. We now simplify this one. So minus 3I1 minus 2I1 and minus 2I1, then minus 2I2, then minus plus 2I3 plus 10 equals to 0. That is equal to minus 7I1 minus 2I2 plus 2I3 plus 10 equals to 0. This is the algebraic equation for the loop A, B, C, E, F, A. Now similarly, we can get the equation for the third loop. Now let us summarize the points for the KVL. Suppose we are moving from A to B, and as we are moving from A to B, the potential drop at R1 is nothing but minus I1 R1, because we are moving in the direction of current. We are moving from higher potential to lower potential. Therefore, there is a potential drop. Therefore, potential drop at R1 is nothing but taken as a minus I1 R1. Now, for the EMF source E1, we are moving from positive plate to negative plate. So this would be taken as a minus E1, and for the E2, we are moving from negative plate to positive plate. It would be taken as a plus E2. Therefore, these are the sign conventions we are going to use while solving the networks, while finding out the unknown currents in a given network, in a given circuit, or in a given closed loop. Example 1, write equations for loops A, B, C, F, A, A, B, C, D, E, F, A using KVL and find I1 plus I2 equals to question mark. Now for loop A, B, C, F, A, we start from A, moving from lower to higher potential, so plus 10. Then for this resistor, we are moving in the direction of current, therefore it is plus, it is minus, therefore that is minus 3 into I1 plus I2. Then we come up to the C. Again, we are moving in the direction of current, therefore it is plus, it is minus. So the current is I2, therefore it is minus 2I2. Now we came to this cell. Now we are moving from higher to lower potential, therefore minus 8 equals to 0, which on simplification gives minus 3I1 and minus 5I2 plus 2 equals to 0, that is equals to 3I1 plus 5I2 equals to 2. Call it as equation number 1. Now for closed loop A, B, C, D, E, F, A, again start with A here, start from A, lower to higher, plus 10, then plus 2 minus minus 3, I1 plus I2, then C, then D, then D. After D we got a resistor of 3 ohms. We are moving from plus to minus, so minus 3 I1 here for this, minus 3 I1. Then here for this we are moving from higher to lower, so minus 9. We came up to E here, E to A nothing is there, equals to 0. So that is minus 6 I1, then minus 3 I2, and equals to minus 1, that is 6 I1 plus 3 I2 equals to 1. Call it as equation number 2. Now after solving equation 1 and 2, we get I1 and we get the I2. Please solve this equation yourself. After solving them simultaneously, we get I1 value and I2 value. Then if you add I1 plus I2, then it will be the desired result. Let us take one more example. Now for this network, first we'll select the loop like closed loop A, B, D, A. Start from A, so that is minus 3 I1. Then for BD, that is a minus 5 I3. Then D to A plus 5 I2 equals to 0. Then for closed loop A, B, C, call it as a E, A, B, C, E, A. For this closed loop, again minus 3 I1, then minus 4 I1 minus I3, then we are moving in the direction of current, therefore minus 2 I1 plus I2. We are moving from lower to higher potential, plus 9 equals to 0. Then for closed loop B, C, D, B, minus 4 I1 minus I3, then plus 4 I1 plus I2, then plus 5 I3 equals to 0. In this way, we can get the loop equation by using KVL. I hope Now you can write the loop equations for any given network. If you have any difficulties in framing and getting the loop equations, please communicate with me on my email address provided in the description box. I promise that I will answer your emails and I will solve your difficulties. That's all for this episode. Meet you again with another topic. Till then, wish you good luck. All the best.